Assalamualaikum and hi. I am AFIQ NAZIRULNAIM bin Muhammad ZAMRI from section 10 for the course SEMM 3242 Instrumentation. So today I'm going to present about the project given for us to develop the instrumentation system that can measure the weight from 0 kg to 5 kg. So for the project background, instrumentation system is a combination of instruments that are widely used as a device to measure, monitor and control the overall process from input to output. Some of the measurement includes the temperature, force, pressure, flow rate and more. For the measurement, instrumentation can be defined as a method to determine the magnitude of a quantity by comparing with the standard value for the quantity. So, the objective for this project is to design and develop an instrumentation system for the measurement of weighing scale from 0 kg to 5 kg. And then the second one is to calibrate the proposed instrumentation system, which is the weighing scale. And the third one is to investigate the accuracy of the developed instrumentation system. So that is the task given for us. So next, I'm going to present to you about the instrumentation system design and how the system works. So here is what you can see is my housing and also the system of my weighing scale to weigh the 0 kg to 5 kg. Open it up. Here is the inside. So for the platform, I'm using the chopping board, the load cell, and also the 1-inch word. For the platform, upper platform, I'm using the chopping board and then the load cell and also the base for this weighing scale, which is I'm using the 1-inch word. So for connecting the platform, the load cell and also the base, I'm using a screw that made those part together. And then this is my connection from the battery to the breadboard to the Arduino monitor. For the system, this is the battery. So the battery will enter the breadboard. After entering the breadboard, the load cell will get the power from the battery, which is the red wire, and also the black wire, which is here and also here. The VA and VB for the load cell, which is the white wire and also the green wire, will enter the voltage follower here. And then the output from the voltage follower will enter the differential amplifier, which is here and also here, the black wire. So for the differential amplifier, here is the R1, R2, R3 and R4 that are followed from with this configuration as shown in the screen. The output from the differential amplifier will enter the Arduino, and then from the Arduino, I'm having the LCD monitor, so I'm connecting the 5V grounding A4 and A5 to get this monitor. So that is my instrumentation system design and how it's worked. So now I'm going to talk about on how to calibrate the system. As you can see from the screen and also from the camera that I've recorded for my system, so the reading is 0.67, which is not accurate because there is no weight on it. So this reading may be because of the plate and also the screw that I've tightened on the load cell. So there will be a reading with the monitor and also here. And then on how to calibrate, I'm going to have the standard weight, which is 0.5 kg, 1.25 kg, 2.5 kg, and I will get the reading from the Arduino Uno readings, and also I will get the reading from the LCD or AD, the serial monitor from the Arduino, reading, and I'll find the average for this system. So I'm going to calibrate first without the mass. So we can see that the measured mass is 0.66. and 0.66, 0.65 and also 0.67, and then I've come out with the average for this first reading with zero weight, and then I add on the weight, which is 0.5 kg, and then I get the reading from the monitor. That I'm plotting the Arduino readings and find the average for the Arduino reading. And then I change it, I add the weight of 1.25 kg and I take the reading again. So from that, I take the reading 1.5, then 2.5, to 2.5. I'm going to add to 3 kg, I'm adding up to 3.75. and then I get the reading from the monitor. After that, I find all average of this system and come up with graph of average Arduino reading against the standard weight. So from that, after having the graph, I'm having the linear equation for the chart to calibrate the reading to be the exact reading. With this linear equation, I go back to the calibration, and here is the coding. So since here is the voltage come out from the overall of the system as for now without the calibration, and then I calibrate the coding by adding the coding voltage. So as you can see here, I have calibrated the system, which is here. So 1.35 is the gradient of the graph. This is the C, which is the y-intercept for the graph, and then from this I'll get exact value for the mass that I've loaded on this result. And then since I found that there will be negative value, which is because of the sum accuracy happen, so I add up with this coding, which is if the voltage output is smaller or equal to 0, then the voltage will be times by -1, or else if the voltage kg is equal to voltage output with this positive number, so that the value will be as here. I add up the coding for the LCD. I think that's all from me. Thank you.